Hi, this is Mr. Manley. If you're watching this video, I would presume that you've seen how to find the determinant of a 2 by 2 matrix. And here we're going to look at finding the determinant of a 3 by 3. Now, just at the outset, I want to say that there is a method for finding the determinant of a matrix it is the method of minors and cofactors. Now that's not something that I'm going to show you how to do, but I want to say it and I want to write it down there so that if you were to strike off on your own, or you were to look at some other method and you were to see this, you would understand, okay, this is another method and this is not the method that I was taught, or the method that you were taught. I'm going to show you what would be considered a shortcut. Now, in a previous video, I showed you essentially a shortcut to finding the inverse of a 2 by 2 matrix. And in this video, I'm going to show you a shortcut for finding a 3 by 3 that does not involve the method of minors and cofactors. Now, the nice thing about minors and cofactors is it can be used for any matrix. So we could use it for 4 by 4, 5 by 5, 6 by 6. It becomes very involved. Even after 3 by 3, it can become a very involved process. But and I really think that, the power of matrices that makes them special is their ability to automate calculations, and it really is very computer based and working on a graphing utility or working in a computer program. So it doesn't make a whole lot of sense to me to do a lot of matrix calculations by hand. But there are some convenient ones here at the smaller level that I do like to teach. So we're going to continue with that. Now, you might recall, if you think about a 2 by 2 matrix, how we found that determinant. You're going to, you kind of see some sort of echoes of that in this. The first thing is not intuitive at all, though. We're going to rewrite the first 2 columns. Just the first 2 columns. And this is just a method of shortcut for a 3 by 3 matrix. Now I'm going to look at the diagonals, and this is kind of echoing back to something that we did with a 2 by 2 matrix. I'm going to go on this diagonal and I'm going to do the product. So what does that mean? I'm going to go on this diagonal and I'm going to do the product. So that's going to be 2 times -4 times 1. So the product on that diagonal is -8. And then I'm going to go on the next diagonal. And I only go on diagonals where I have 3 numbers. So I'm not going to do 5 times 6. Okay, I'm going to skip right over that. So I'll go on the next diagonal here, and that's -1 times 2 times -3. So what is that? That's going to actually be +6. And then I'll go on the final diagonal here, and that's going to be -4 times 5 times 6. So that's 30 times 4, so that would be -120. And then I'm going to actually find that sum, those sums and differences. So I'm going to do that calculation, and that'll be what? That'll be -128 and then +6. So that's going to be -122. -122. And then I'm going to do this in the other direction, so to speak. So I'm going to go on the downward diagonals. So I'm going to go down on that diagonal, and that'll be -3 times -4 times -4, which will be 16 times -3 is -48 on that diagonal. And then down on this diagonal, 6 times 2 times 2, which will be 24. And down on the final diagonal here, 1 times 5 times -1, that'll be -5. Okay, and then I'll go ahead and evaluate all of that. What is that? That's -53 and +24. So what is that? That's 29, right? Or -29. 49, 53. So that's 29. And then from there, I'm almost there, the determinant is going to be equal to the bottom number. So it's going to be negative 29 minus the top number. Like that. So this is going to be negative 29 minus a negative 122. So we'll call that 122 minus 29, and that'll be 9. It's like 93. So that's equal to 93, and that is the determinant of this 3x3 matrix. Again, this is a shortcut for finding the determinant of a 3x3. There is a method for finding the determinant of any matrix called minors and cofactors, which we are not doing here. And we are understanding that this matrix may have some application, or it has some application that just depends upon the context in which it is being applied.